Welcome everyone to another exercise in the workbook Statistics. This time we're going to talk about an exercise from the area of probability theory. Let's have a look at the exercise. Here we have, at the university, students can study in one of three study programs: NM, RBM or PM. The distribution of the study programs is 47%, 31% and 32%. Additionally, we know 19% of the NM students do their semester abroad in Spain, while for RBM students it's 62% and for PM students it's 37%. Our first task, based on those information, is then determine the probability to do a semester abroad in Spain, or that a randomly selected student will do his semester abroad in Spain. Second, assuming at a partner university in Spain you meet a student, what is the probability that he studies RBM? And finally, third part, what share of the students study RBM or do not study in Spain? Well, let's take a look at those three parts step by step, because in part they're also building on each other. So let's start with the first one, with the probability to do the semester abroad in Spain. Well, I'm just going to write this down. Probability of doing semester abroad in Spain. Here simply shortening this to P of S. What we know? Well, we know all the different shares for the study programs. That's this part here. With the, if we look closely, added information that they add up to 100%. And we know the conditional probabilities conditioned on the study programs that someone will study in Spain. So we do not have this absolute, this total probability, but we have the conditioned probabilities, and we have here for the condition distribution which adds up to 1. And well, since we can also assume that every student studies in only one study program, we can assume that the different study programs are disjunct, meaning the probabilities add up to 100% exactly. Well, if we have information like this, this always is a good indicator to use the theorem of total probability, which looks in this case like that. And it's nothing else than multiplying always the conditional probability with the probability of the condition actually taking place. So those two, those two, those two, and then adding them all up. So in other words, we can also understand this as something like a weighted average of the conditional probabilities, weighted by these weights here. If we then take a look at the final result here at 39.99%, that's also a good way to control whether we worked in a decently well fashion, so whether our result actually could make sense. If the total probability is something like a weighted average of those values, needs to be between all of these values. Well, here we have 39.99, so more or less 40%. 40% lies between the smallest and the largest of these values, pretty close to the other one. So it's actually really something where we could expect this to be the weighted average of those numbers. So that's why this result, at least, we do not know whether it is absolutely correct, but from a first look we can directly decide this is a result which actually makes sense. So that's a believable result. Well, and that's also part 1. Finished and done. And in part 2, we're now looking for a conditional probability again, but now with the conditions reversed. So now we're looking for what's the chance that someone studies RBM if he does the semester abroad in Spain. That's what we gather from you meet him at the partner university in Spain. So he studies there. What we know? Well, first off, we know the probability of studying in Spain. That was from part A. We know the probability of studying RBM. And we know more or less the exact opposite conditional probability also from the exercise, that if he studies RBM, the chance of going to Spain is 62%. And whenever we see something like this, we have this probability given with the condition here, and that's what we are asking for. And then those two switch places. And that's what we're looking for. That's a very good indicator for using the theorem of Bayes. Theorem of Bayes in this case would look like this. That's the probability we're looking for. And you see here, that's a probability we already have. Then we multiply this with this part. The upper part, the first one here, is the condition from the conditional probability which we are given, which we have, divided by the probability of the condition we are looking for. So well, we have all three values we need here. So if we insert them, we get as a final result 48.06%. 48.06%, that if I meet a random student in Spain, he will study RBM. So roughly 48% of a chance. Well, that was already the second part. So let's turn to the third and final part. Here we're looking for this probability. He should either study RBM or not do his semester abroad in Spain, or both of these aspects. Well, how do we get about this? Whenever we see something like this, a union of events, that's usually a good indicator that we're going to use the addition theorem. For the addition theorem, we need the probability of the first part, probability of the second part, and a probability that both events take place at the same time. Well, what do we have? From the exercise text, we already know the probability of studying RBM. From part A, we know the probability of doing the semester abroad in Spain. Here, however, it's about not doing the semester abroad in Spain. That's why I use the complement here. Well, if we are interested in the not doing this, then we can simply go with 1 minus. That's a probability of studying in Spain. So 100% minus this one. Here is 60.01%. That's a probability of not studying in Spain. Finally, well, we need a probability of studying RBM and not doing a semester abroad in Spain. Here we can take a short roundabout way to get to this. So first off, we're going to determine the conditional probability that if he studies RBM, what is the probability that he will not study or do the semester abroad in Spain? Well, we know from the exercise the probability of studying in Spain under the condition RBM. So if we want to have the complement here as well, we can simply go with 1 minus again. This only works if we're looking for the complement here. This does not work if we have the complement of the condition. But well, in this case it works, gives us this intermediate result. This one we can use with the formula for the conditional probability, but solved for this probability of studying RBM and not doing the semester abroad in Spain, which in this case would simply be conditional probability, this one here, multiplied with the probability of the condition occurring. So those two values multiplied gives us the probability of both events taking place at the same time. That more or less follows from our decision tree. So here we get as this probability 11.78%. Now we actually have all the information we need for our addition theorem, which in this case would look like this: studying RBM, not doing a semester abroad in Spain, minus studying RBM and not doing the semester in Spain. Well, if we insert the values, we get as a final result 79.23%. So roughly 79% of all students study RBM or do not go to Spain, or study RBM and do not go to Spain. Well, that's then everything there is to this third and final part, but also to the whole exercise. I hope you enjoyed this exercise. I say goodbye and see you next time.